So I'm going to do a bit of Luke. The QR code for Slido. If you have any questions throughout, please do there. So today, I'm first going to introduce myself. So I'm Oliver, software engineer at Monzo. This is my family. So there's my partner, my son, and my dog. So these, every day, this is my life. So I just thought I'd introduce myself a little bit. I've been at Monzo now for about a year, nearly about a year. I actually joined with Lucy on the same day. So we're very much aligned. We're almost like twins at Monzo, actually, funnily enough, joining all the same sort of projects as well. But in terms of what I've been working on at Monzo, I've been doing lots of different things. I've been working on anything from building our newer payment system for paying someone, all the way to our new incentives like gifting, which is coming soon to you. I've been using Swift for quite a while, and I've actually worked with quite a lot of you in this room, so it's lovely to see some familiar faces. It started with Objective-C, if people remember that one. And I'm now part of the Swift 6 language mode and concurrency adoption working group, and you just heard a little bit from Lucy about what the working group means, and I'll go into a little bit more detail about that later. But today, I'm going to talk through our journey transitioning away from DispatchQueue into Swift concurrency, and why that transition is necessary and challenging. But before we get started, I kind of want to set us all on the same page. What is concurrency? Because it means a lot of different things to different people. So concurrency, simply put, I got this from the dictionary, is the ability to execute multiple tasks simultaneously. But why does it matter? Because you can build an app without concurrency. You don't need it. You can very much do without. But for us, it makes sure the app is fast and responsive. We want to make sure that when you visit the Monzo app and you're scrolling down the feed, that you have a really good experience. We are primarily a mobile banking service. We don't have in-store, so that experience has to be the best as possible. And we do a lot of things in the background. So we have a completely server-driven UI. Some of the models get really, really big. And parsing all of that and fetching them and then delivering that and parsing the models and showing it in the UI can get very expensive. When you activate your card, so when you get a new card through the post and you take a picture of it and you scan it, there's a lot of processing that goes on behind the scenes. You need to make sure that you process each frame to recognize the text that's on there. That can get very expensive. We use it to search your transactions. So when you click on that search button and you start filtering through, there's a lot of work that goes in. You might have thousands of transactions, and if you're one of the early adopting Monzo users, you may have 8 years worth of transactions that you've got to search through. All our transactions are stored on device in Realm, and they are synced. Yes, we do use Realm, and yes, we've heard the news that it is going away. So the elephant in the room, yeah, for sure. And yeah, Realm can get very expensive, and I'll touch a little bit more on why Realm actually makes a lot of this transition quite complex. And I'm going to dig into a couple of concepts in relation to concurrency that are quite relevant to working in this world. So threads, locks, and queues. So a thread is like a really low-level thing, and one important concept is the main thread. And the main thread is where all of the UI operations hang back on. There's actually also a very special secret thread called the animation thread. So if you ever see a little spinner that goes on when you stop the main thread, that keeps going. That's because it works on a separate thread. But the main thread is a really important concept, as you don't want to block it. You want to make sure that the main thread is kept as lean and quick as possible. And that's why we do a lot of background processing. An analogy for you. So I imagine describing threads to somebody who doesn't know about programming, I would say it's like a kitchen where you've got different chefs, you've got all the waiters, and you've got the head chef, the main thread, and you've got all different kinds of chefs working, and they all produce a dish, and then you kind of distribute that dish out. So threads function like these individual members of staff, all working to make a dish. They're really good because they make use of all of your CPU cores, but they're very complex to manage, and they don't have things like run loops by default, which is what helps you cycle. They're very prone to race conditions and other things like deadlocks and thread starvation. So you can create as many threads as you want, but there's no saying how many you can have. You have to look at how many CPU cores you have, and then you have to start distributing work. to make it effective. Very, very difficult. And there's a very high overhead in creating and maintaining them, not even just for the resource on the system, but also the developer having to manage that. It's really complex. Moving on to a lock. Really, it's just to control access to a shared piece of resource. Yeah, so mainly to prevent like a data race, so you can't have multiple threads trying to access something at once. And my shark is kindly demonstrating here. Imagine you were in an office where everybody needed to use this photocopier. If everybody did that at the same time, it just wouldn't work. Chaos would ensue. So you have to have some way of managing access to this photo scanner. And a simple rule could be only one person use the scanner at one time. Yeah, so that's pretty much what a lock does, is it allows you to prevent other things accessing it when somebody else is using it. And there's many types of locks that we can have. You have like mutex locks like NSLock, recursive locks, which is like a mutex that can attain multiple times. And then you have these unfair locks, which are really like low level, and they're based on priority. So they don't release themselves if they, based on the order they were taken, they're released based on the priority of the thread that asked for it. And there's this new one in iOS 16, not so new anymore, but called OS Allocated Unfair Lock. If you haven't looked at it, take a look. If you ever need to do any locks, this is probably the one that you want to be using. They're really good because they provide synchronization between threads, so you can start doing things across all of these different threads. But they can lead to deadlocks. So if you take a lock, hop threads, and forget to release that ever, or you have a thread waiting on another thread for a lock, you can create yourself a deadlock and things pause. I'm sure we've all experienced something like that in the past. And there is a performance overhead with them that you have to worry about because you're preventing forward execution. So you're literally telling the thread, stop working and wait for me until something else happens. But they are still relevant today. So they're not completely outguarded. And actually, even within Swift concurrency, you still want to be using them. And actually, it's a really important part of how we're going to be helping migrate these things across, because making things all safe for Swift concurrency is very difficult, which I'll talk about soon. So locks are a very good way to kind of like help us there. And then finally, we have the queue, where we have this like lovely animation of these bags rolling down. So queues were actually introduced as part of Grand Central Dispatch, or GCD, is often abbreviated to, fairly early on, I think iOS 4 or something like that, because direct thread management was so complex and no one really wanted to do that. So Apple introduced this concept of queues, so you don't have to worry about what thread you're going on, but actually instead you just shove things in a dispatch queue and then you hope everything is good. Yeah, you hope. There's a couple of kinds of queues that you have. You have serial queues and concurrent queues. So serial queues are often used for executing one task at a time, where you want things to be safe, and concurrent queues are when you actually don't care, you just want something to run. I imagine a queue a bit like an airport baggage handling system, where the baggage handlers put the bags on the conveyor belt, and then the conveyor belt is an automated system, and it routes it to the right plane. Yeah, that is what a queue is much more like. It takes away that complexity of figuring out and getting the baggage handler to take it to the right plane. The automated system does it. So they're really simple to use, and that's probably why it's been a staple part of developing iOS apps for so long. They're really good at managing themselves efficiently as well, so they'll allocate to different threads and as they see fit, as resource gets high on one and low on another. And they provide a lot of high-level abstractions, so like dispatch groups, if you want to group multiple things together, and all different types of prioritization when you're working with them. But they do come with some downsides. There's no type-level constructs, so you as a developer are required to figure things out, making sure that everything is OK, because it's impossible to improve at compile time. And doing so introduces some funny problems, because you often get a report from a customer saying, my UI is stuck or things crashed, and you don't figure that out until you get a crash report. We use queues a lot at Monzo, like a lot. I think I did a search and there was nearly over 1,000 usages of custom queue, which is like more than I've ever seen before in anything I've done, and I've worked with them a lot. It's really easy to just add a dispatch queue main async. We've all been guilty of it, to work around a problem. And even worse, if you do async after and think, I'm just going to throw this away because I don't want the bug, and a small delay just kind of gets away from that. So they're really powerful to use, but they create quite complex solutions here and there. And you can often end up with fairly nested problems. But they are really good. And I can't go without talking about Combine. So it's not going to be like the primary focus, but it is Apple's answer to reactive programming, RX, as some refer to it at least anyway. And this is something that we did think about at Monzo, but we didn't actively pursue because the barrier to entry for Combine is quite high, and Apple don't seem to be maintaining it. They've almost like silently deprecated it. There's been no updates ever since it was released. And even now in modern standards, if you try to use it with Swift concurrency, you're going to have a really bad time because it's essentially treated as an app pre-concurrency import. You have no closures that can be marked as sendable, so if you're looking at cancellables and things, which makes it, if you're trying to work with all these new Swift 6 compiler mode, you're really going to have a bad time because it's just not going to work. It's not going to work out the box. But there are some tools that exist in Combine that don't have anything in Swift concurrency, like a subject or multicasting. If you want to do that, that just doesn't exist in Swift concurrency. There's open source libraries to kind of like provide some of these tools, but primarily they don't do that. And no surprise, there's a new kid on the block, Swift concurrency, and they released this as part of Swift 5.5. And it's their modern approach to concurrency in Swift. It's fully integrated into the language, so cool. And because of that, it improves all the safety, because at compile time, we can check what's going on. You can make sure that you're not doing naughty things, because I'm sure we all sometimes do, at the compile time. There's a ton of tools inside of there. So we have structured concurrency, we have actors, and then you have tons of other things like that we can use, like locks and queues as well. So you may ask yourself, like, why? Like, what's the point? Why are we going to move away from DispatchQueue towards Swift concurrency? Because DispatchQueue is really powerful. So it wasn't actually an easy decision to make, and doing it now felt like the right time. Swift 6 is just about to be adopted in the Monzo code base. We're starting to get lots and lots of warnings about that. And it also feels like a much more complete feature of the language. I don't know if you've ever used Swift concurrency in 5.5, but it was like, most things would just crash, and you had very, very little things that you could kind of do. We also want to make sure that we can catch these problems that we have with data races at the time the developer writes the code, rather than waiting to get a report from the customer. And as I mentioned, we use Realm as our local DB, and it's really error-prone when you come to accessing it, data from its model. So you have to be really strict about what queue it's been accessed on, and that creates a real problem with Swift concurrency, as the way that it works is like there's like a pool of threads that it can, or pool of queues that it can use. They call it like the queue pool or something like that. And you don't know which one it's going to have. So as soon as you have a suspension point in concurrency and you do an await, you have no clue. So it means that you have to like freeze objects, or you have to like transfer ownership between them. And yeah, it makes working with Realm very difficult. They came along and said they're going to deprecate Realm, so that kind of like is going to force our hand a little bit in kind of getting rid of it. We also had to introduce quite a lot of complexity in the app to make sure that we don't release broken software. So tons and tons of different types and weird code to dispatch, and doing it away. And in fact, the other week, I just fixed a bug around our new feature gate system, which is our like feature toggling, like true and false rollout system, where we'd get some customers report that the app would just crash on the launch, which is like the worst thing that you could ever do for someone. And it turns out that there was a data race when we're trying to synchronize the cache inside there. In concurrency worlds with actors, that wouldn't have been possible. And on top of everything else, we want to modernize and future-proof our code base. Yeah? So looking forward, we want to make sure that we're using the latest and greatest tools that Apple's offering. They're going to be building all sorts of debugging tools, I hope, to kind of like figure out what's going on. And one other thing is the Android team earlier this year started to look and migrate to coroutines, which is Kotlin's version of Swift concurrency. So we can speak the same language with the Android team when it comes to some of these problems. And on our back-end systems, we use Go, which is heavily based with Go routines. So again, we can have a lot of the same conversations and a lot of the problems. Lucy mentioned something that in 2 weeks' time, we're looking at adopting SwiftUI. That's also going to be true for Swift concurrency. So we're moving to something called reference architecture, but just think of it as like an architecture that's like unified. So we have like SwiftUI, Swift concurrency. We also are using the composable architecture, and we're using all of this together, and we're taking it up and doing it as a unified approach. And Swift concurrency is going to be at the heart of that. So for our state management, our data and networking layer. So all of these things are built from the ground up. So everything looks perfect, right? No, not quite, because it's not easy. And actually, there's a lot of things that Swift concurrency takes from you. It's difficult to learn for people who have used Grand Central Dispatch. There's a thing called beginner's mind. If you're new to learning about Swift and Swift concurrency, you'll have no problem with any of the concepts, and you'll get it. Yeah, I've not found someone who's new that's not been able to catch it on. But if you're learning it from the perspective of having Grand Central Dispatch knowledge, then it's very difficult to understand some of the mind shift that you have there. So I'm going to take a few minutes to actually go through a few of these problems and show some code, because what's a talk without a piece of code? And then explain some of these common pitfalls, and then go through some little tools and utilities that we wrote to mitigate some of them. So this is a seemingly innocent piece of code. We think it's okay. And in, say, for example, a dispatch world, if these were dispatch main async, or sync even, they would run in order that you create them. This is not true in concurrency. There is no guarantee about which one will run first. So it would be very easy for this one to accidentally notify before it is finished transferring the funds. Also, the second one silently hides the failure. So there's no one actually listening out for that, and it's very easy to just create that problem. But this is a really silly example just to kind of demonstrate it, but these implicit relationships will exist everywhere in your code base, and they will happen whether you know about them or not. So understanding order and about when things are going to be working is really important with concurrency. The next thing is lack of caller control. In the old world of dispatch, you could say, well, actually, I'm guaranteeing that something's going to run on the main queue because I'm going to dispatch and then call you. Yeah, so you can kind of guarantee that. So it's controlled by the caller here. But in Swift concurrency, that flips its model on its head, because the isolation context, which is how things are working in Swift concurrency, is attached to the definitions themselves. So a little bit like this. So here's two examples. Don't worry that the balance is just an integer. Two examples. You have a kind of a local actor here, and then you have something over on this side called the global actor. And actually, you can create more global actors if you want. But the main actor, think of it as like the main queue, similar to that, where you're telling this type should be run on the main. So things like UI view controllers are automatically marked with this here. It flips the model on its head. So I think this is actually a better model. But when coming from DispatchQueue, you're really not used to that, because you think, well, actually, wait a minute, I need for this to run, and you start reaching for tools like main actor.run, and actually, how do I start forcing myself into calling things there? But the good thing is the compiler helps you along the way, so you really can't make too many mistakes here. And by the way, there's different kinds of isolation. There's two here. There's like local actor isolation, where everything inside here happens within the actor. There's global isolation, but there's also another third kind, which is like no isolation. So it's just wherever it's run at that time, which is also fine. And that's great for synchronous work or work that you just want to happen within some other isolation context. And then we get sendable. Sometimes you can get very cryptic errors. And they keep coming, and you get really annoyed because you keep having to fix them. It is getting better with each version of Swift, and how you fix them is also improving. So the auto fix. Sometimes it's a common mistake that people make is like just mark everything sendable, and if I can't, I'll just uncheck it and mark it uncheck sendable and just get on with it. Non-sendable types are also fine, by the way, so keep them around. Don't forget about them. And don't forget about global isolation as well. So when you're working with things, isolate to some sort of global actor, and that's also fine. But yeah, unchecked sendable and non-isolated unsafe is a way to kind of work around some of these problems, but use them with caution, because they may feel like they solved the problem at the time to kind of get you past the compiler, but then you're going to run into the problems that we try to run away from DispatchQueue, where you crash in front of your customers, which is not good for maintaining trust and reliability. Problems with actors specifically is reentrancy. So this is a very interesting problem. So here we have an actor that allows you to withdraw some money from there. And what we do is we check, is the balance larger than the amount? Very simple. We then create a suspension point where we say, hey, sleep for a second. It's in nanoseconds here. And then we minus the balance from the amount and say, withdrawal completed. It seems very innocent. Now, imagine you call withdraw twice, just after each other, then from different contexts. Because you've created a suspension point here, this check is going to be true the next time it's called, while it's still waiting. So then you're going to end up in a position where the balance goes negative. And this is, again, a very simple example about how a small suspension point inside of an actor can create a problem. So you have to be really careful when you're designing actors and you're using checks and creating suspension points about kind of structuring your code. Yeah. So, but what does it mean for us? And how do we, take large pieces of work at Monzo? Lucy's alluded to a lot of this already. So here we go. So the beginnings. The first step was to try and form a working group. And when I say try, it's not just like you say, hey, I'm going to create a group, and then we're all going to get together and start doing stuff. Yeah. There's a bit more nuance to that. So every 6 months, we have kind of like a discipline planning session where we all bring our ideas to the table, and then we decide as a collective discipline about the kinds of things that we want to work on. So because we recently are just about to update, you heard it here first, our minimum supported iOS version 15, and moving to Xcode 16 and Swift 6, it felt like a right time to start thinking about, well, actually, do we start thinking about concurrency? So we need to submit our idea as part of the half-year discipline planning, and if accepted, then the next 6 months that we'll start working on this as a working group, recruiting members, and dedicating time to solving. Yeah. So the group is responsible for identifying pieces of work, so actually figuring out what we need to do. That's a really key part. At the time of forming the group, we know that there's a particular domain that we need to solve, but we don't know the exact nuances about what we need to solve in each. Larger pieces of work get it in the form of a proposal. So the working group is responsible for building these proposals if there's large pieces of work that need to be done to share with a wider discipline. So one of the first things we do is actually we create a place on Notion to start documenting all of this stuff. I won't go into all the details, but we create what is the purpose of the group, a little summary for those, some guiding principles. You'll start to notice a pattern. The Swift UI group had some very similar kind of topics there. Swift concurrency is a slight bit different because this is a framework built into language from Apple. So there's quite a lot of existing resources that we can attach. There's no blog post for Monzo design system, but there is for Swift concurrency. So we can link to WWDC videos, provide links to books and documentation, and so on and so forth. We have sections for guides. So this is where members of the working group decide that they want to do some sharing, knowledge sharing, and they go along and they build some documentation that says about how they want to use something. Finally, there's some, we did some sessions, and I'll go to those in just a moment. Okay. Here we go. So next in the list, so after we create the hub, we started and created a new module called Monzo concurrency. And Monzo concurrency is a place where we want to put everything related to the tools we need to migrate our code base to concurrency, and also filling in the gaps of where things were essentially not there for some really useful tools that we relied on quite heavily with the DispatchQueue, but we didn't quite have in concurrency. Some really simple examples, like just being able to link and create a piece of async work with a completion block, and making sure that's done safely, so you can like hold on to it and like cancel it and things. We also have versions for throwing and things like that. We also have some operation queues that go on in the app for managing sequences of events and limiting how many things can happen. So when you're performing a kind of like the common example that people use for operation queues is like managing image data. Yeah, so you kind of like pass it through. You don't want to handle loads of images at once because the app hasn't got that much memory. Yeah, so we use a very similar tool here in there. We also have two other tools. Actually, Lucy wrote this one at the bottom, so thank you, Lucy, for this contribution here. And this is all about how we handle failure cases and kind of like timeouts. So if you have something that you want to retry so many times before you decide that you actually throw an error, we had some really nice tools in DispatchQueue for this. It doesn't exist in Swift concurrency, so we built and made it even nicer to use. You will notice that there's a little bit of combine there, so any scheduler of. We still have to support iOS 15. The new clock APIs are only available in iOS 16. So for this moment in time, yes, we do have an import combine schedulers in the code base. And that's, you know, there's tons and tons of other tools. So we have tools for all sorts of caching types that use actors for replaying stream values, buffering streams. And we have integration with some common open source libraries like Swift async algorithms if you want to start doing more complex things as part of your data source, or Swift concurrency extras, which provide a lot of useful tools out of the box for testing. So if you are interested, check that out from Point Free. If you're doing anything in Swift concurrency, you probably need it, as it makes testing deterministic. And the next thing was the sessions. And this is a fairly new addition and something that is actively ongoing. So not even there yet, but in the process of planning. But I thought I'd give you a little sneak peek into some of the things that we're going to be doing. So these sessions the aim of them is to bring everybody up to speed so everyone's on the same page. So when we talk about some of these concepts and start using them, that we have this documentation that provides a workshop-style interface. We record the sessions. It's like pair programming. People are open and encouraged to ask questions all the time. And we save them, the videos, so people can go watch them later if they weren't able to attend at the time. We transcript them so you can search them and you can figure out exactly what it is, what you need, and when you need it. And it isn't something that we can do overnight. This is, by the way, there's loads more in here, but I just couldn't fit it on the page. But just Swift in its own right, there is a lot of code in there. And there's a lot of usage of DispatchQueue. And migrating our code base to that is an unthinkable task. Yeah? So we have to come up with some sort of strategy to enable us to do it, but also safely, because we want to make sure that we don't just spend the next 6 months rewriting things for the sake of it. Yeah. It's also, I'd like to note that there's never been a rewrite of Monzo codebase ever. In a lot of apps, people think, oh, screw it, let's just rewrite. And I think that is a staple to the way that Monzo works and develops, is that we don't just rewrite things. We formulate a strategy and a plan and come up with it and incrementally adopt some of these new technologies. Fortunately for us, Xcode 16 and the Swift 6 compiler is really helpful. They have different modes of Swift concurrency checking, You can have minimal, which is like, don't bother. You then have targeted, which kind of like ramps up a little bit, gives you some sendability warnings and gives you some checking to make sure that you're not introducing races. And then you have complete checking, which is like, you know, the bee's knees, and that is everything. And you really know then that things are going to be safe. And you can do that both in Swift 5 and Swift 6 language mode. Swift 5 mode is a little bit more relaxed, and Swift 6 mode is like the good version that you want to be aiming for. So for us, we eventually want to have everything with strict concurrency and Swift 6 compiler, but we can't do that from the get-go. We first have to identify some modules, and actually the recommendation from Apple, which is maybe counterintuitive of what you might think. You may think, well, actually, I'm going to start by adopting it at my Leaf modules, so the very low-level modules that I'm going to be reusing in all my libraries. Actually, Apple promote the inverse, that you isolate it to features, you migrate those, and you work your way down. Because the more things that you share, the code that you share, you then have to start updating all of your modules. So if you update a core library foundation module, like Monzo core or something like that, then you would have to update all the features that depend on that to support concurrency. And it makes it a very difficult task. So you start at your feature level, and then you work your way down. It can be a little bit annoying because you think, oh, there's these things and I know that I can do them. And sure, you can create a module specifically for that, and if you want to do it, but primarily stick to that. So focusing on isolated modules, feature modules at the start, and working our way down. The compiler will guide you as well. So the compiler is like really good in Swift 6. It will pretty much tell you what to do. And if you didn't want to do it all at once, you can enable concurrency features one by one. So you don't have to enable the full strict checking. You can enable targeted mode and then decide there's some flags that you can pass to Swift-C compiler that allow you to say, well, actually, I just want to enable this actor reentrancy or data race problem. Yeah, and you can incrementally do that so you're not having like these really big pull requests that are updating all at once. Want to use tools like the OS allocated unfair lock for things where we know things are safe, but we can't guarantee that to the compiler because we're using some Objective-C or we're using some old dispatch code that we don't want to refactor. Then it's OK to use some of these tools that Apple's provided to help with that refactor, and also some of the tools that we've built around in Monzo concurrency. Mark what is necessary is the main actor. So people often get scared of putting things on the main queue. Feel like, oh, actually, no, it's too complex. The phones in our pockets are really powerful. Actually, they're probably not used enough on the main queue. We do too much work on background queues. So it's fine. You put it on that and just base your decisions on results. And if you do some instance profiling, don't just make an assumption. Yeah, see how it is and see how it runs. And when it's not possible to guarantee all this kind of stuff, then sure, mark it unchecked sendable, but or mark it non-isolated unsafe, but do it as a kind of a last resort. So to kind of summarize, enable targeted concurrency checking mode, enable complete checking, and enable Swift 6. And do this module by module, and we progress, go on. The documentation that we've provided in the Notion page goes into more detail about how you can do this and some of the tools and help that you can use in order to kind of achieve that. So it is a learning curve, and it will require a lot of effort, but you can do it, and it's worth it. So from the features that we're already using this in, I think we've got 12 now or so features built using this reference architecture. We've really simplified the whole building of features at Monzo to the point where it's really delightful, and even non-iOS engineers find it very easy to kind of look into. Build tools to help you. So don't just rely and everybody implement their own. So build the tools. Read all the guides from Apple. They're actually quite documented, quite well documented. Quite often, people just jump into it and think, I'm just going to do it and just fix it. Actually, there's a lot of help that they provide. So yeah, make sure you read that. I would set up a working group. It's worked really well every single time that we do it at Monzo. So if you think considering it, for sure do that, and add automated checks where you can. So if you use Danger or use other tools that do some automatic reporting, scripting and such, include those as part of it. You know, you can do linting. You can say, well, actually, you know, these things, you know, I don't want to introduce any more, you know, particular naughty paradigms in there. Take them away, and you can put a linter rule to stop you from doing that. We are still in the really early process. So SwiftUI is the group has been going for about a year. This one has not even really started. So we're in like season 0 right now, not even season 1. So maybe next year we'll talk about season 1 of concurrency. Yeah, cool. So that is kind of our journey, and well, the start of our journey to Swift concurrency. Go on then. Be gentle.
Okay, the first one. Excuse me. Love the beginner's mind. As a primarily JavaScript developer, the continual evolution of promise resolutions really resonates. Are there any tips for GC peeps to adapt? Did GC mean Grand Central Dispatch? Yes. Okay.
Yeah. So probably what I would say is the best way that I've found this is I treat it as a new language. So when you're coming from Grand Central Dispatch, it's very much like working in UIKit and you go to SwiftUI. Everything feels tough and like it's fighting against you. It's best to just throw away that prior knowledge you had and try and build a new relationship with concurrency and think about it differently. Do lots of small demos. So, you know, if you're coming into it and you're trying to get a piece of work done, that's when you're probably going to stress most and you're going to get really upset because you're trying to get all this thing done and you're like, well, actually, I need to deliver this thing and this thing's stopping me from doing it. So give yourself a little bit of time and also respect the fact that it is new and that it will take a little bit of learning, and the learning curve is a little bit steeper, but the barrier to entry is lower. So to get good at it, at least anyway. So yeah, just give yourself the time, I would probably say, and work on some small examples.
Is there perhaps one kind of prior bit of knowledge that you may carry over from GCD that is massively unhelpful? That is the first thing to sort of jettison in your learning how to do things?
Yeah, so the one that kind of sticks out to me is when you want to do a bit of background work, you just create a new DispatchQueue and you just fire some work to it async. That has been like best practice in terms of DispatchQueue for a long time. And it's very easy to get into the habit of actually, I want a bit of background work. I'm just going to, you know, in concurrency, we'll spin up a new task, do the work, and then just forget about it. Really, you want to make sure that you take advantage of the tools that concurrency offers, like structured concurrency. So you have things like task groups for kind of like grouping pieces of work together and performing them in a loop, for example. You also have you know, inheritance of priority automatically, which you didn't with dispatch queues. So you don't have the problem of priority inversion as much. You can still get it. But there's all these, so dispatching to the background queues is a very easy way to kind of forget about that kind of problem. The main problem that you'll see if you use a semaphore, a dispatch semaphore, that's not good. You will block the concurrency pool, and it will basically, your app will just freeze in a really bad way. So if you're using semaphores, you have to be really careful about when you create and release them. So that is a very foot gun. Actually, I forgot to mention that, that kind of using it. But I think the knowledge of, hey, I'm going to do a piece of background work, dispatch it, do some work, and then dispatch to the main queue and update something. That paradigm in itself is really kind of like, you know, it's like a bit of a mind virus. You want to get away from that if you can.
Next question. Is there a persistent solution you're moving to?
Oh, Realm. Yeah.
One that works well, cross-thread. Core data has many concurrency challenges as well.
Yes, it does. So we have not spent much time. So Realm have been speaking to us, and they're looking at deprecating it in about a year's time. So they've deprecated it now, but they're providing support for another year on the library. So that gives us a little bit of time to evaluate our options and figure out what we want to do. So naturally, there's going to be some decision-making process that we're going to have, probably working group, et cetera, et cetera. So Swift data may be up there. There may be some other examples that we look at doing, like SQLite or GRDB as like a wrapper. But I think that's going to take a little bit of time and investment to figure out exactly what we want to do. I wouldn't be comfortable in saying like which one we're going to go for, but yeah, something like that.
And I actually missed this sort of announcement. It's news to me that Realm is getting deprecated. What's the background to that? Why are they doing that?
It's just not a profitable model for them. Really? So MongoDB bought Realm. This is not a MongoDB talk. So, MongoDB bought Realm, and they opened up their cloud, like Firebase kind of esque platform, and it just didn't make money. And the cost of that for them running it is so high that they're just deprecating that and focusing entirely on MongoDB as their backend solution, no SQL database.
I guess Firebase being so kind of...
Firebase being so prevalent, yeah, and you have things like Superbase as well. It's like an open source alternative to Firebase, and there's quite a lot of new great tools now. And actually, the phones in your pockets are pretty powerful. You know, you don't always need that kind of like sync. You have iCloud data as well. So there's a lot of solutions that already exist that you don't need that kind of synchronization. And actually, we don't use Realm for their cloud solution. We use it for our kind of on-device. So at least we have localized our problem in a way that we can just replace things on device. If you're interested, Android did this same migration away from Realm about 2 years ago. I think they moved to like Room, I think, or something like that, Room DB. So they have a lot of experience that they can share with us about their migration and about what they want to do. So we'll be speaking with them to figure out what some of the steps they took and what was difficult, what was not so difficult.
Well, sorry, whilst we're on Realm, you said you had some issues with the concurrency stuff around how it was accessing it.
Yes.
And what's your kind of interim workaround for fixing those problems?
Yes.
Quite important.
Yeah, sure. So we have a concept called a data source in our new unified architecture, which abstracts the way fetching a piece of data. So what we did as part of here is when you work with Realm, if you're fetching from the DB and you're making a query and doing filtering, the point that you want to use that in cross-isolation context, we translate that into a domain model. So we convert this like very mutable, thick DB class into a much safer sendable struct that you can safely cross past isolation domain. Now, it does mean that if you want to cross back that domain, if you want to do some writing, that you do have some complexities there, but they're not too complex problems to solve, and you can very easily perform diffs and things about what you want to write. So primarily, it's the conversion between the database model and the domain model that allows us to then safely do that. And we built that directly into data sources, so it becomes part of the contract. So you can't use Realm in the new unified architecture without having the ability to translate it to a model that is safe to cross boundaries. And that exists for both one-off fetches, but also streams of Realm's observations. So if you're performing like, hey, I want to watch all my transactions and update the feed, then yeah, that model also exists there. Yeah, there you go.
I might miss it, but you mentioned like you've got your operation queue type helpers. What are you doing for like multicast? Is that in the stuff building libraries?
When you say multitasks, do you mean?
Multicast, as in like subjects.
Multicast. Okay, yes. So it doesn't. Multicast is obviously not part of that. We do have some types that take in either a stream or an async closure that allow you to then buffer and share that between. So task itself does do some mechanisms of that, but it doesn't do sharing a stream value. So we have built some kind of like cache wrappers that kind of like sit around that type and do that. Maybe we'll open source these, but yeah, there was quite a lot in Monzo concurrency that we had to build specifically for that, especially around sharing Realm streams. Like you don't want to create multiple subscriptions there because they can get expensive because they watch the disk. So you want to make sure that those expensive operations like that are backed by this kind of like shared tool. And also, if nobody else is listening anymore, that you cancel it. That you don't want to have maintain an open subscription when nobody's listening for the kind of the database anymore. So we built some types around that. There are open source alternatives, like in ASIC algorithms, there's the channel, and they also have a broadcast algorithm that's not quite been merged yet, but maybe soon. So maybe there'll be some open source things there, but we have built a fair few types in order to help with individual values, values paired by a key, and then streams of values.
Quite a few more on Slido. So how do you start to find areas where concurrency might help, and how to avoid early optimization?
Yes, it's a very good question. So really, it comes down to the kind of the core principles of what we want to use concurrency for. So we want to use concurrency for networking. So when we want to perform an asynchronous operation and kind of get a result back. That's a fairly obvious case, but then there's not so obvious cases where you have things like a cache and you want to share a value. Like, should that be in concurrency, or should you just protect it with a lock? And that really depends on how you want to consume that. There's cases where we have decided not to use concurrency. So for example, when we built our feature gate tooling or feature flag tooling, there's a lot of places in the legacy parts of the code base or parts of the code base that don't use concurrency that we want to use this tool. And it becomes a really poor trade-off if we say, well, actually, you can't use it unless you migrate. So we use it in the new code, in the new architecture, but it's not always the case that we're going to introduce something and build it in concurrency. We may build something and build it without and use locks. The OS allocated unfair lock is a great example of that.
Next question. Working groups have proved useful at Monzo. How do you succeed in running them? Where should I start?
Yeah. So I find it useful for speaking to people who have already run a working group and who have put some time and effort into building documentation in a working group, and then getting support from some of my peers around that as well. To get started, I think the only person stopping you is probably you. So I think get yourself into the thick of it and start figuring out what some of those problems are. The best way of learning is to kind of get into the mix and figure these things out. I thought I knew what it meant to form a working group, but then I made one, started to make one, and realized there's a lot more to it than just kind of what meets the eye. So putting yourself in that position, I would say, is the best way to learn.
You mentioned the composable architecture. How come that's attractive to move to? What are the learning curves, and they seem quite steep?
Yes, good question. That deserves its own talk, I think. But to kind of like briefly kind of go over that. State management, so the way that we currently manage state in the app is we have a view model and a view controller, and they're connected via a closure that provides updates and say, the model's updated, you now need to go and do something and request a property off it and do that. That works, but as soon as you come to need some more things, like if you have different places in the view that can update, you then introduce multiple closures. And management of state gets fairly complex. There's obviously other tools that you can do. So RX-style programming where you can bind to certain properties is also a valid solution. When kind of evaluating, we had to make the decision, and by the way, this is all before I joined, but when we were evaluating, had to make the decision, do we build our own thing in-house, or do we look to the wider community and see what some of the popular frameworks are that provide first-class and world-class documentation and help for onboarding? It's not something that if we built our own tool that we'd be able to provide as well as the team at Point Free. They're really good at providing helpful documentation, video tutorials. They go around and write amazing blog posts. Caveat, we do have a dependency on them now in that respect. So that's a business risk that we have. But it's open source, and we fork the repositories. And we actually contribute to the repositories as well. So we often find some issues in their libraries, like Swift Perception, for example, which is their backport of the SwiftUI observation. And we've made several fixes into that repository, as well as some of their other repositories for like issue reporting and such. So I think adopting a third-party framework is always a tricky situation, especially when there is a steep learning curve, because it's not as simple as the view model architecture. Actually, the view model architecture is the most simple we can probably get as iOS developers. And the increased complexity for the composable architecture is also a risk, but it's one that's a trade-off. And like everything is a trade-off, you have to decide on whether you think the trade-off is worth it or not. And as a collective discipline, iOS discipline, we decided that it supported all of the right ideas that we wanted out of it. It was SwiftUI first. It provided us with state management that allowed us to test really easily. It adopts Swift concurrency primarily as a mode of dealing with asynchronous work. So yeah, it's not an easy decision, and I think only time will tell whether it's the right one, but we believe all the things we've put in place and the analysis we've done determines that it should be one that kind of lasts.
Two more questions, if that's okay.
Yeah, go for it.
Time is against us. Do you find using non-isolated functions to do more work on a background thread?
Well, no, I mean, it depends on where it's been called from, because non-isolated just means it can run wherever you call it. So it's fine to do it on a background thread. Ideally, so this typically happens when you have a protocol and then you conform something that is actor isolated on it, and then you have to make that thing non-isolated, and then you have these protocol functions that you can't do, and you have to either assume it's isolated and make it unsafe, or you have to do some work and actually create tasks and kind of execute that. I would ask if you're kind of creating these things and does the protocol itself need to be marked as the global actor that you're using it within, so that you can isolate it to there? Or is it truly non-isolated, and do you care about where that is being run? So we talked about the mental model of changing between DispatchQueue and Swift concurrency, and isolation is one of the biggest shifts because you control the isolation at the time you write the function, not about where you call it. And that mental model shift does change that. But in terms of like where things are run, Swift concurrency should make that easier to understand, not more confusing. But it does come at a different, it's different from DispatchQueue. So yeah, I guess the model there is slightly different. So maybe is the answer.
Very long way to say maybe.
Yeah.
Final question then. How do you identify and monitor when the app crashes when loading? How do customers make you aware?
Yeah. So we have a crash reporting tool, so we use Sentry for that. We try and do Sentry the first thing that we do before we do anything else, so that we can capture things fairly early on. When you have a crash within something early on, like loading up feature toggles, which you really want to be the earliest thing possible, ideally, it creates quite a tricky situation because maybe it's not available in time for the crash reporting tool to have hooked into the SIG crash, so for you to actually do the reporting, or maybe it's not enough time to actually go and report the crash. So if it's a crash that happens all the time, then we rely on the analytics from Apple because they provide it based on the OS. But if it's not, and it's something that happens infrequently, then we can catch that as part of Sentry because it will be uploaded at some point. We also have extensive automated tests that we run and manual tests that we run. So we run all sorts of different testing parties. We run it as part of a team. We run it as part of a discipline, so where we do larger scale changes, like actually dropping iOS support. We'll be testing that as a discipline. And then we also have days, so Monzo, we have these things called collectives, which are groups of teams. And then we also get together and do collective testing. We do polish days where we go through these larger scale problems that we have, little minor problems, and go through and fix them. Maybe that's included in some of them. So yeah, we just use the tools that are available, like Sentry and kind of like stuff like that. External test flight, yes, we do that every week. So if you're not on it, get on it, and we do external test flight feedback. Well, actually, we do get a lot through that, to be fair, where our really keen users want to test the app before it goes to production, and they provide us a ton of insights. And obviously, it's all through Apple at that point. So we get the crash reports from the device as opposed to through a third-party tool like Sentry, which may not pick everything up.
Fantastic. Should we give Oliver a round of applause? Thank you.
There we go.